This is the first of the exam review videos for Chapter 8, Video 1. And in Chapter 8, you were working with polynomials. So the topics that were in the first part were working mostly to take polynomials, add, subtract, see where they came up in different calculations. And in the second part, that's where we spent a lot of time factoring and moving into solving quadratic equations. So in the beginning, in the first part, you had to learn the vocabulary of all the polynomials that we might be working with. So putting things in standard form always meant that they needed to fall in that ax to the highest power and then plus bx to the next highest power and so on down the road. So that by the time you're done, the powers were listed from highest to lowest. So in number 1, what that would look like is your first term would need to be the highest degree term, which is the negative 2x to the 5th term, followed by, so I'd already have taken care of that one, followed by a positive x squared term, a positive 3x term, and a positive 9. Keeping in mind that the sign in front tells us the sign on the value, not the sign after it. Why don't you pause and get all of yours into standard form. After getting it in standard form, and I'm going to do that one really quickly, then you want to categorize them by degree. And what we learned about degrees was that degrees mean the highest power that's on the variable. So in our case, the highest power on the variable is a 5, so this is a 5th degree. And if you see in the directions that it gives you choices. Constant means a degree 0 on the variable. That means there isn't an x to the 0. First power would be linear, second power is quadratic, third power would be called cubic. After that, we just say 4th power, 5th power. So for instance, the one below, that's just 12 in standard form, its degree is 0, or you could put constant because it's showing you that there's no powers on x, there's no x's. So you'd either say 0 or constant by name. Pause and fill in the rest of the degrees for your terms. Then the number of terms. Terms begin and end every time you start a plus or a subtract in between quantities. So when I go to add or subtract. So in our first expression, there are 4 terms. If it's 4 or more, then it just is called a 4-term polynomial. In our next one down, the one that was 12, that's only a 1-term, and so they have specific names. Monomial for 1 term, binomial, trinomial, that deal with the number of terms, and that might be vocab to get onto your note card. After you finish the table, then you're going to start working on some of the problems where they have you add and subtract polynomials. And you want to think about adding and subtracting like a shopping list. So in number 5, you've got a single list here, and they're asking you to subtract the next list here. And you want to be careful that you actually know what operation is going on in between these two. Because it's subtract, we're going to keep up our plan of keep. Some of you liked change flip, keep change change. I called it keep add opposite. Whichever way you remember that, is that subtraction can always be written by keeping the first list or expression and then changing that subtract to an add, and then we have to change the sign of everything. So negative 3x squared, minus 6x, and plus 3. It's as if that negative distributes to each of the terms is another way to think about it. Once you're done writing it that way, then we need to pause, and then we need to go into our combining like terms step, because that's all adding and subtracting can do. If we're called upon to add 2 things, they have to be like terms in order to make a simpler expression. So I'm going to go through in the highest power order. I see only that as an x cubed expression, so that's my only x cubed. Going down a power, negative 5x squared and negative 3x squared can combine and make a total of negative 8x squareds. I see a positive 4x term and a minus 6x's, so I have a negative 2x when I total them. And finally, just my poor old constant at the end, plus 3. So you want to be careful with subtraction, thinking about how you're going to carry that out. Number 6 is an addition problem, and you can pause and do that. Number 7 is a problem that asks you to use it in context, meaning they're going to give you a situation. So find the perimeter of the shape below. So perimeter is always the sum of all the sides. So in the part where we're asking you to practice adding expressions, perimeter, and that's a good keyword for on your note sheet, is asking you to add up all those sides. So take a minute, start it with one of them, 3x squared minus 2. Add to them, work your way around, 5x squared plus 3. Work your way around to that next side, 3x squared minus 2. And work your way around finally to that 5x squared plus 3. Then you need to do the same thing we did above with the subtraction problem. You need to go through now and decide which of your terms are like terms and can be combined in order to make a simpler expression. So be sure to finish that one before you leave that problem.